Are you really like I feel okay.
Good evening, welcome. My name is Kimberly Blackpink Dunn. I am the director here in the ignITe Hub. So officially, I'm welcoming you here for our spring guest speaker series. This is our first event for this school year, or this semester, I should say. Can everybody hear me? Do I need the microphone? No. So first of all, I hope that you enjoyed dinner. We had our Fiesta Mexicana, and I would personally like to thank Verizon. They are the sponsor for our guest speaker series this spring. So thank you to them. Thank you for their sponsorship. Tonight is all right. All right. Thank you so much. So this evening, this is our Fireside Chat career series. And just a quick commercial about the ignITE Hubs. I see some new faces here and I see some returning faces. So both of those things make me very happy. The ignITE Hub is the newest innovation center here in Montgomery County. It is a partnership with MCPS, Montgomery County Public Schools, Montgomery College, Montgomery County Economic Development Council, and Apple. This is an Apple-equipped lab. We have 30 MacBooks, 30 iPads here in the hub for our programming. The hub is brand new. We just opened in May of 2022. So we are just ramping up here in our programming. We have 4 programming areas. High-tech learning, which means we have courses, and maybe you've heard of the Montgomery Can Code Summer Camp. That all is sponsored here under the hub, as well as courses. Careers, which is part of the reason we're here tonight. We're going to hear about some amazing careers. Business and entrepreneurship innovation. So we want to connect a pool of tech talent to a pool of people that need that tech talent. So that's in that area. And then community education, which again, our speaker series also fits in that category of educating the public about technology and entrepreneurship. Those are 2 areas that the hub focuses on. So again, I'd like to welcome you to the hub, and I'm glad that you're here to learn more about our services. So back to Fireside Chat Career Series. This is a monthly speaker series that we have where we invite experts in our community to come and talk about their career journey. One of the things that I've heard in my time here at the hub is the IT pathway is nebulous. People don't know how to navigate, right? They don't know what the options are. We all hear that it's a great field to go into, but what's really entailed in that? So the speaker series is intended to bring individuals in to talk about how they've accessed the IT or entrepreneurship pathways. We want to make it more accessible for you, your family, your network, to say this is a place where you belong and we want you here and we're going to support you with that. So this evening, we have Carter Rock here. We had the presentation is the network of nerds, how the Navy influenced the design and recovery of NASA's Orion capsule. So this evening, we have 3 guests. This is new for the hub. Usually we have just 1 speaker, so we actually have a panel. So I'm excited about that. Quick story, or maybe not a story, but a shout out to Tink here. When we had the grand opening here in May at the hub, Tink was the first one to come up to me and say, we want to partner with the hub. And so this is our 3rd collaborative event, actually, in the 9 months that the hub has been open. So this is the start of a great partnership. So thank you for initiating and being collaborative. So this evening, Tink Lauren Hanyok is here. She is the Capital Tech Bridge Director, and everybody here is with the Naval Surface Warfare Center, Carter Rock. Does everybody know where Carter Rock is? No. No idea. Okay. We're going to have show and tell this night. It's right here in our backyard. It's very close. We also have Ryan Hanyok, who is science and technology photographer, and Mark Melendez, who is a mechanical engineer. So I'm going to have them introduce themselves, but before they start, maybe we can welcome them with a round of applause. Thank you for coming this evening. Great. I'm going to turn the mic over and I will turn it over to you. Thank you.
Actually, I do have to give a shout out to Dr. Joe Teeter because he said, this thing, I got an email, this thing is happening. And I was like, I'm going. So thank you. I'm Tink. My real name is Lauren. Tink is just easier to hear and say. And my program director a long time ago decided I was the antithesis of Tinkerbell, and it stuck. And I don't think well, you weren't the one that did it, but I don't think you've called me Lauren in a long time. It's Tink. So I'm the Capital Tech Bridge Director at Carter-Rock, which is this type of work, engaging with the county, doing these types of collaborative events, supporting Dr. Joe Teeter. He's our tech transfer director, so it kind of works all together. And then the other half of what I do at Carter-Rock right now is facilitation type events. So trying to help people think better, faster, stronger about coming to a solution quicker, bringing all the ideas in the room, stuff like that. Lots of sticky notes end up happening. But yeah, that's what I'm doing right now.
So I'm Brian Hanyok, and yes, we are related. We are buried. We actually met each other way back before we even started working at Carter-Rock, and through happenstance, that's actually how we actually got there. Jumping ahead, you probably talk about how you became an engineer in a bit, but I have a strange path. I started out in high school thinking, oh man, I'm really good at photography, and my parents were like, yeah, anything so you don't do drugs. So then got into photography, studying fine art photography down in VCU down in Richmond. And that was a great education because that helped me think not just like, how do you take a photo? Why are you taking this photo? Why are you doing this? Why is what you're showing matter? And then Lauren Tink was an intern at this weird place called Carter-Rock, said, hey, you should come visit. I came and visited, and they're testing this giant football field of water, these waves just going, and like, this is a bizarre place. And I met a photographer there. And he was like, I need an intern. You want an intern? It's like, go, sure. But the place was just so cool, just blew my mind. How could you do photography in that way? How could you utilize those skills that I'm learning in fine arts, and you do science with it? Long story short, I started my own internship there, learned about everything that Carter-Rock does, and all the science involved and all that sort of stuff, and went down that technical path for quite some time and loved it. And through that, got to experience so much of the science and technology development and design and all the things that we do for the Navy through quite literally a lens. And it's a great way to like just yeah, it's a great way to experience all that stuff. And it's really cool to start like that project. We were working on a ship design. We weren't quite sure how it was going to operate, and now it is many years later now out in the fleet. Very cool process to see all that. And it was not a path that I could have had without just meeting some people, talking to people, and taking advantage of, sure, I'll try anything.
Hence the network of nerds. Everything was literally a network. Oh, and by the way, if you have questions, just raise your hand. Discussion. We don't want to sit here and talk at you. First question.
So do you have events at your place?
At Sorry.
Not really for the public. Not too long.
Oh, the events that we do at Carter-Rock.
What kind of stuff are you thinking of?
You allow visitors to
Submarine races. That's open to the public.
Yes, we don't typically have to we are a research development facility for the Navy, so it's not open for the public. There is a subway on base. You're not going to get into it without a badge. But we do have on our biannual event a thing called International Submarine Races, which is a really cool event that takes college university teams to build a human-powered submarine, where you literally put students into it and they bicycle pedal, and through naval architecture designs try and build the fastest submarine to get down one of our basins that are at Carter Rock. Pretty cool.
We do have some pretty great STEM internship opportunities. So in that way, yes, we have programs where folks can come in. We've got high school interns, we've got college interns, and there's a bunch of different avenues. And that's one of the collaborative events we did, was explaining all that. So we'll probably do another one. But yeah, we do have those types of things. And there are tours that kind of relate to those sort of events. But let's talk about Mark.
Again, Mark Melendez. Let me see, I started back right before Tink came on board, and she was interning while I was working in the group, and we were testing DDG 1000. At the time, more so I was just a general engineer, but I did a lot of design work for the model that we tested in the basin. And you'd say, you tie into some background. When I interviewed, I went to school down in Florida at Florida Atlantic University. And when I interviewed, there were two people that were interested. One actually was a group from Philly, and then one was in Code 55 at the time. And they said, essentially, we work in a big wave pool and we test model boats. And it was like, there was that, and then there was the foundry in Philadelphia making massive props. And I was like, I think I'd like to play with boats in a big wave pool. I mean, it was, the foundry was cool too. I would have considered it, but it was Philadelphia too. It's kind of like, yeah, man. Sorry. Yeah, if anybody's from Philly, my apologies, but I've been working at Carter Rock now, oh my gosh, 21 years. But I've jumped around actually in different places on Carter Rock. Did 12 years in the Mask Basin, and then went to electromagnetics for 4 years, and then went to a machine shop group where we did stereolithography, AM, and metrology, and then ended up back in Code 80 in hydromechanics with the facilities. So it's jumping around, but we use a lot of technology and we integrate as much as we can when we can. Sometimes we can get stuff that's more cutting edge, and sometimes it's a little bit older. But we make do with what we have, and we have to proof out ships, and we have to proof out parts and other things, and it's definitely interesting.
Oh, good. I realized they like did their whole career path, and I'm just like, I work here doing this one thing. So my career path sort of started similar, worked in the mass basin, maneuvering and seakeeping basin, which is just a giant couple. Yeah, if there's acronyms that you don't know, just be like, please explain that. There's a lot of acronyms in the government. It's how big is it?
360 feet long by 240 feet wide.
It's so cool.
And a third of it is actually 35 feet deep. We call it the trench for some deeper stuff if we need to. But at 20 feet deep, it's 12 million gallons, I believe, or 13.
It's a lot.
13
Then there's you can find pictures of that online. There's a cool photo that you shot actually that was in Popular Mechanics. Well, we can geek out about that later. So I started as an intern the year before Ryan came on as an intern. You were working in the Mask. So I kind of came up on, or I guess cut my teeth on doing acquisition systems for testing model boats in a giant wave tank, which was super fun. I did that for a long time. Learned a lot about how to get all the sensor data from the model into a little computer, do analysis on it, and then eventually got into how do you make the model do what it's supposed to do? How do you know where you're supposed to put the weights and how weird it was. And I realized we're just using an Excel sheet to do that. There's nothing fancy here. There's math, but like, I was like, oh, okay, this is cool. It's like putting a puzzle together. This is really neat. And then after that, I was in a leadership cohort that actually Ryan was in the year before, and they required you to do a rotation. And the project, the Orion Capsule project that we're going to show you a bunch of pictures and talk about in a second here. We had done that in 2008, and in 2017, 18, I was supposed to do this rotation with this leadership cohort, and we happened to have we happened to take a leadership class at OPM, which is the Office of Personnel Management, but they have a lot of cool classes there for leadership, facilitation, actually, and a bunch of other things. But we accidentally ended up in a higher level leader class, and we were a bunch of not leaders yet. And actually ended up saving the class. We were the right amount of people to make the class go forward. It was really weird, but we met two people from NASA, and they were like the people that have their faces on the internet. So you know that they're really high up in the leadership because you could look them up and you're like, oh, you're on NASA's website. Wow. Like, that's awesome. And so after conversations with them and realizing some of just the insights that they had in the leadership course, I was like, maybe I can rotate with NASA because we did this project with them and we have a detachment down in Florida. So it wasn't really a leap. We talked to our leadership and they said, yeah, sure, go do the thing. So I got a chance to actually check one of my very large bucket list boxes, which was to work for NASA. So I got to do that for 6 whole weeks, which was really, really very cool. And then from there, that's when I moved into, I did a rotation at organization out of ONR called Naval X, where I got to learn more of the facilitation skill set that I mentioned earlier. And then, oh, thank you. Office of Naval Research. Thank you. Yes. Just shout out questions because we're going to blow right through our acronyms and we apologize in advance. And then I moved into our additive manufacturing group, which is 3D printing, super cool things. Did some digital engineering with them or digital manufacturing with them. And then I got a chance to take the Capital Tech Bridge role, which is sort of related to that Naval X organization through the Office of Naval Research, where we're kind of tagged in with all of the other sister commands and everyone has an engagement arm. And so I get to work with them on a semi-regular basis, which is pretty cool. And that is how I got here. But on to more fun things. So the picture that's up right now is a picture. And so there's only 3 of us up here on the panel, but these are all the people that were involved in this. And there's not everyone is even in this picture. So the faces that are circled are us, just to show you where we are. That's not true at all. You're a horrible person. They're all very much alive. But yeah, so what you see in the back there is a full scale, yeah, I'm gonna let you talk about it because you know more about it. Tell us.
All right, so that's the full scale Orion capsule boilerplate. And that is basically, it weighs the same and is ballasted where we put the weights and everything. So it actually inertially acts the same as the real thing. And we had decided on putting stickers there because we didn't need anything complicated at the time to represent the windows and the rocket locations for directional stability and such. We had a generic simple hatch at the time that they were going to replace later on, and they just wanted the backbone, the frame of the capsule. They wanted to be able to practice on something. And Tink had kind of, I can't remember the whole story of how you steered them to Carter.
Tell it. Okay, so this is what's so great and this is why the Network of Nerds, you're going to hear lots about networking. That is me as a small child. That was in 2008. I'm pretty sure that so I normally wear t-shirts and jeans, and I'm pretty sure that we knew that we were supposed to be being photographed that day, which is why that is what's happening. Um, so what you're seeing is the quarter scale model, which is the larger one, and a 10th scale model on the screen. But so what had happened was one of our friends at Carter Rock had a friend at NASA. They happened to have a conversation, and NASA, the team that was working on the Orion, which was called Constellation at the time, that was the name of the program. Yes,
That's what I ended.
I don't think so. I think it's just like the constellation Orion. NASA's going to be like, it's wrong.
Kind of like Apollo, like the Apollo program, the Orion portion of that.
Good question, though. I didn't think about that. Because in my head, I'm seeing it like uppercase, lowercase, but not all uppercase, which could have been, but you wouldn't know. And anyway, so friend had a conversation, and they were looking for some place to test the capsule because they had not tested the previous capsule before in any significant way. So the person who worked at Carter Rock, who had this conversation with his NASA friend, he was like, you work in the big way, you work in the mask, right? Like, I have a friend at NASA who wants, this is how the conversation went. I have a friend at NASA that kind of needs some work done. And I was like, can you please say that again? Because I'm going to go to my boss right now. And so I did. And that is effectively how we got the collaboration, which I thought was super weird. Do you have things to say? Okay. I was like, it was cool because I wasn't like a high level leadership person. This is my second year, I think, second-ish year. Yeah, tiny thing. Yeah, there's a mark. Yep, you're totally in that picture. And that was all that it took. It was a simple connection between a few people that said, okay, this is something, there's a there. So let's check that out. And so our boss at the time took lead. He put a lead engineer on it, and then I was able to, oh my gosh, that is a picture of me. That's a normal picture of me. And then I got a chance to work on it, and Mark was pulled in to do a lot of the design. So a lot of the stuff that you see, not this one, but the smaller one, and then the larger one, Mark did a lot of the actual design work on it. Add some stuff.
This was the quarter scale model they brought over. They wanted to figure out how to test it in our long tank. They wanted to know how it would be towed in the water, just like that. Yeah, they wanted to make sure that if they're going to tow it, they're not going to flip it over or get water in the hatch if there was an opening or whatnot. When the capsule lands, if anybody saw the landing of Artemis when they dropped in the water, pretty charred up. And at the time, they thought that a lot of the tiles were going to be eaten up from that reentry. And so they wanted to know how it was going to settle in the water after a lot of the tiles were burned away. Inside the capsule, they actually have an inner mold line, which is airtight, and outside of it, where kind of those blue straps are in this picture, those panels are floodable. And so it would be way down, but still floating. And initially, they did not like the way this towed. When they were doing the testing, you were on the test, actually, on this test. I wasn't on the tow test, but we were prepping for some things, but this did not go well because it was diving and kind of trying to go under the water. As you can, yes, as you can see there, and that's, yes. They had some antenna and other things up top that they just wanted to protect. They weren't sure if it was going to get wet or not, and so it was just yeah. There were some sensors up there, and they didn't want them to get wet, and they just this was an easy way to throw it on there. Yeah, it was. They were also testing that skirt around it. NASA at Kennedy Center was tasked with designing the skirt, how it would wrap around the capsule, and then how the parajumpers who would come and retrieve the astronauts would engage the capsule in the water. And that was the primary reason they came to us, because Alan Rhodes found their way to us, and the parajumpers and the Navy rep was Commander Andy Hewitt. And he was asked if, how many people and how would we interact with this capsule in the sea up to a certain sea state? And it was kind of scary because they were talking about sea state 6, which is no, it's not 13. It's, I can't remember the exact wave heights. Yes, it's, oh gosh, yes, will be, it's high, it's big, and the comparison that we always referenced was the deadliest catch in Alaska, that kind of sea state potentially, because one of the spill points for the capsule was going to be off the coast of Ireland, the North Sea, and the North Sea is notorious for having really bad and rough seas. So if they were going to dump there, they wanted to know how many people, how we approach it, what assets we would use, et cetera. And when they asked Commander Hewitt, he was saying, well, the guys that he would assign to it, they're like, we're not going to do anything until we get something to practice on. And that would be a boilerplate. And they'd actually have a boilerplate in the Smithsonian at the Udvar Hazy there. And they actually, my 2 colleagues went on that field trip. At the time, my wife was pregnant, so I did not go on that field trip, but they went and looked at that boilerplate to get kind of a feeling for what was designed so that we could replicate it. And also oh, yes.
Sorry for the interruption.
No, it's okay.
So was it the first time that it was done, or prior to this something similar was?
I don't know the deep specifics of everything, but effectively, we haven't done something like this since the Apollo missions. Yeah. And the Apollo capsule was like 3 tightly packed astronauts, whereas this could hold up, I believe, is like 6 or 8. Yeah, along with a lot more stuff because we've gotten a little bit better at space travel. So that iterative steps of, okay, let's rather than just go to space, find out and come back, that's extremely expensive. So just doing that iterative step of, okay, let's build something. Okay, let's see how it operates in the water. Let's build something and, literally get our hands on it. How does it feel? How does it look? How does it react to stuff? Actually, if we can advance the slides, 1 or 2. It's a guy taking data, and that's going to the test pond. So here, for example, you're not going to toss it out at sea in that sea state 6, the deadliest catch situation right off. You're going to start in somewhere controlled like a pool. And so these are the parajumpers, they're Air Force. These would be the guys and gals picking up the astronauts who are coming back probably from the International Space Station or Mars or the moon. And chances are they will have been in space for quite some time. So they're going to come in weak. They're going to have a bad time. They're going to be shook up. And if they land in the seas that are not so pleasurable, they're going to come in sick. And Lauren has some data on that. And so being able to crawl, walk, run, and every step of the way, not only with the science of like, how can we characterize this? How can we measure or perhaps predict what's going to happen given any scenario? Literally, how does it feel to wrap that skirt around? How hard is it to do in a still pool? Put out in slightly more adventurous situations where maybe you have to deal with wind a little bit more. How does that feel? And just keep going and going, and just to find out what the little limits are, so that we're not surprised when the astronauts come landing.
Yeah. So what Ryan was alluding to is so the picture that you see on here is just super cool. It's our explosion test pond, and that's kind of what they were seeing underneath the water. We didn't do anything explosion-y for this, but it's a very cool capability that we have. But for the other thing that I got to do that was very cool is while we were working on this, I was getting my master's degree in ocean engineering. I had previously, my undergrad was in aerospace engineering at Virginia Tech. And I did not know what I was going to do with my thesis. I was like, I like waves. Waves are cool. But then as we were doing this project, one of the first things that I had done at work was looking at motion sickness and something called induced interruptions, which is actually a metric that was developed by our previous boss at Carter, which is how many times you end up having to task switch when you tip over, like on a boat or something that's moving. So it's all based on accelerations of, what the boat's moving and doing a whole bunch of things. You're like, oh, okay, now I got to go back to work. Oh, okay. So it's basically that fancy word for tipping over and losing your place in whatever you're doing. So I got permission to take the data from the work we were doing and measure all of that, which was very cool. And Ryan gets to play with the slides. And so we got to measure all that. And as Ryan, stop touching things. So as Ryan was alluding to, I wouldn't want to be on that capsule when it comes down because the astronauts would not be very happy at all. And but it was very, very cool. And as we were doing that type of work, it wasn't something that they had requested, but it was data we were able to give back to them. So it was really exciting to be able to do academic work for, oh, hey, it's you. It was cool to be able to do academic work while for something that I was really interested in. And
So we got this goofball Lauren here, Tink, in the capsule. Obviously, everyone wants a picture with the NASA work. NASA's fun and cool and stuff. Next, the person to her left is Trisha Shields. She was the connection to, oh, there he is, Scott Duncan, who had the friend at NASA. We would not have known Scott, and Scott would not have known Lauren without having that connection with Trisha. And just being able to make all those connections, like over lunch, what do you do? What do you do here? Like, do you know anybody who can help me solve this problem? Like, I didn't realize how much this picture encapsulated that. Mic drop. But so it's just a really, don't drop the mic. It's really interesting that this network of stuff that we're all doing, it's all fairly fluid, and it's just really cool to have those connections. You can't have them unless you like actually meet people, just talk to your coworkers, stuff like that. It's neat stuff.
no, that was good. But my story was over about getting my thesis done. I just like the fact that I was like, I did my thesis on NASA, and my thesis advisor. So once it went up, we have data from the test articles, as they were called, but I don't have any data from an actual capsule. So I kept oh, it'd be great if I could get data from the Artemis mission that comes down and see what it is. So my thesis advisor was like, yeah, just when NASA calls and they give you the data, just call me and we'll work on your PhD. I was like, oh no, that's not the thing that I'm ready to do. But that would be really cool. Yes. Yeah.
One of the colleagues, Rich Banco, worked for the Towed Bodies group in Hydro, which was kind of our sister group. We did maneuvering and seakeeping in the Mass Basin, but they did more towed bodies. And so they knew a lot of the characteristics of towing anything, whether it's a sonar array or something to that effect. They looked at it and advised on what type of maybe a drogue chute that they could use to slow it down and actually change the attitude of it when they dragged it through the water. And that actually had an impact, because if you saw Artemis, by the time they came around and actually had the landings, they were using, I think, a rib and just putting it in reverse. But where they attached to and how much force they applied to change the attitude and then keep it in line with the ship when they were towing it was all kind of done from Carter advising them. And they also, we did talk about how it hits the water, how it's going to, there were two modes of basically how it's going to be in the water. One is stable up, which is upright, and stable 2, which is upside down. And the upside down was going to be a concern because the hatch and the upper hatch were going to be underwater. And so they had also, in addition to the skirt, I don't know, you have an image of the 3 balloons on top. Oh. Okay. Well, there it is. So they had kind of already done this design, but and then they wanted to attach those as well as the skirt at Card Rock and the explosion pond. They did it even before when we were ballasting the vessel. And that would make sure that it actually came upright and they would still be able to get to them, because otherwise it's a 20,000-pound object that's very stable upside down and not as stable right side up hydrodynamically. Yes.
So this is not
Oh, that's out in the open. That actually is off the coast of Kennedy, off the coast of Florida. Actually, yeah, it was Ryan with Rich and Todd. I just had my first child born, so I was not on this test. So, this was the boilerplate. Yes, this is the boilerplate that we made, and they took it on kind of a tour down the East Coast, went to Kennedy, and then actually did the test in the water with it, and they were practicing on it. And for a good portion of a week, was it 5 days? Oh my gosh, 2 weeks. But I don't know the other pictures necessarily, but there were some pretty hairy sea states that they were operating in, and yeah.
So how does this work? Once you have all the tests done, that's when they make something similar to this to actually use it.
I'm sorry, one more time.
Once you do all the tests,
Mhm.
once you say yes, it passes everything, then they're going to make one of these to actually use it.
Yeah, well, they'd already started their design. Lockheed Martin actually designed the capsule, and we matched their physical characteristics. They told us what it was going to weigh at that point, and a few other things, gave us an idea of the shape and where things would be. We had replicated a lot of the internal tanks with just representations of foam or whatnot, anything that would displace the water and give it that characteristic if it was flooded or if it wasn't. So it would sit in the water just like the real thing. So we did that to advise them more on the hydrodynamic side, the naval architecture side. The one guy I worked with, Todd, was a naval architect, and Rich was an aerospace engineer, and he guided us. He was a senior engineer, and he guided us a lot. But I spent the better part of a year in SolidWorks, if anybody uses SolidWorks, with that on the screen, trying to get all the pieces together and assembled from the various input. This is the full scale model, and the ballasting conditions were all over the place. They had one condition where I believe if they had come in for just normal reentry after their mission was done, it was somewhere around 16 to 17,000 pounds. But if it was fully loaded and they had to do an abort during launch, it was closer to 21 or 22,000 pounds. And so we actually had cast an ingot of lead that we had. It was 1,000-pound ingot of lead inside there, and we put it on a linear slide inside there so that we could change the way that it listed in the water. It's kind of its attitude in the water. And we actually even had another piece of lead that we used for ballasting it when we did it on land. But there were even other things inside there that were interesting that we could show you pictures of, if we have them all.
So this is not like making widgets, right? So how many full-scale models you make, like 4 and you test all of them and then pick one for the actual application?
Well, with this one, NASA funded us just for the one. The smaller models, the quarter scale model, actually Johnson Space Center did that one and brought it to test in the tow tank. This one we actually took on as if we were a contractor, as if we were Lockheed Martin or somebody. And we manufactured it. We have a sizable machine shop in-house at Carter Rock, and they made almost all the parts on it. And then we had them welded down in Hampton, Virginia. And so we were traveling down there all the time looking at this stainless steel weldment and advising them, giving them part. We would bring parts and they would continue welding it. But we made the one, and then we could ballast it differently so that anytime they made changes to it, which they did, lots of changes, by the time you get to the end, you can still use this as the skeleton to hold different weights or move things around and see how it still acts. So it was a reusable unit.
And I think to get to your question about multiple bits, like you said, we were just, no, you're good. We were like one cog in the machine, and NASA did make multiple versions for different tests, and we just did the one back there.
Oh, how do you move 1,000-pound weight in the capsule?
On a slider with electronics.
It was a linear actuator. It had just a decent sized motor on the end of it, but since it was laid out flat like this table here, it was on a slide, and it had a screw drive, and you would just move it slowly. It wouldn't be fast, but it would move. And it did help actually, because at one point we started taking on water when it was in the explosive pond, and they were going to pull it out and they couldn't reach one of the hooks. And Todd, my colleague, said, hold on one second. He pushed the button, and they waited there, and you watched the thing just kind of start going like this, and then they were able to hook up and pull it out of the explosives pond.
So you go back to the picture with the crane. One of the things that, so I guess we weren't here for this, but so one thing I also want to say, Ryan took almost every single picture here, almost all of the video that Carter Rock was responsible for. Ryan did all of that. He was our one-man photography band for this project, except for the ones that he's in. I might have taken that one. But to the question of like, how did we influence some of the design? Not only did we get a chance to influence design, we also were able to influence, like you were saying, about what kind of drogues do you need? This is an example of something we were able to say, you shouldn't do this. And so as far as the recovery of the vehicle, Ryan was able to see some crazy stuff.
Okay, not to get anybody in trouble, but as you see there, we're lifting it off the back of this is NASA's booster recovery ship. It's what they use to recover the boosters from the space shuttle and other rockets or other things they need to recover. It's pretty sizable. The crane there, should just pick it up and bring it out over the water and put it down. But like a normal boat, or it should be easy, right? Well, when you're out at sea and you're trying to find big waves to test in, not necessarily deadliest catch type waves, but the boat starts moving, and as you can imagine, things start pendulating, and the the capsule was swinging like crazy, and it could have, if it had one more swing, taken the crane with it, and who knows what else would have happened. We knew in advance that was a possibility. In fact, NASA, being a very risk-averse organization, because when you put something in space, you can't do anything else about it. Like that's it. You get one shot. Here's $1 billion shot. And so they're very risk-averse. So they work through absolutely every problem. Risk-aware, certainly. Yeah, they put things in space. That's very risky. Todd Carrico was coming from the Navy's perspective is, okay, we have to try this. We have to accept some more risk. And so there's a lot of back and forth discussing what the best way to do things like this. How do we accept this kind of risk? And we knew it might pendulate and we might have to release it. So it was just a person completely dedicated on pulling that pin to release the thing if it need be. And when it did, it went flying and sploosh. Good splashdown, mimicking what it would be like from coming back from space a little bit, but very scary to actually see that happen. And in many ways, it's good to have that mix of teams, both Navy folks who have got a lot of at sea experience with NASA folks who have, in many cases, none, and the folks in between who run the booster ship who can kind of interpret between the two. That really was actually the breakthrough for that particular thing. Of course, that day we decided to tow it back rather than try and lift it back on the ship, and that's how we. Yeah, just pretty much the rest of the time, like, let's not take that risk anymore. We saw what could happen. We all agreed that was not, that was scary. So. Yeah, that was a serious consideration too. Yeah, oh, if people are in there, why don't you just pick it up with the crane? But there's so many things that could go wrong with it. That is an option should a situation arise. They know the risk now. They have a better sense of how to characterize that. That's why they tow it into a ship, an LHD, I think, LPD.
Landing platform. Oh no.
I'm gonna get you more in trouble for not knowing your acronyms.
Oh, gosh, yeah.
It's a type of ship.
A large ship with well deck where they could actually bring it in and tow it in, and they have a floating stop that literally they would tow it into, and also a bottom piece that would cushion it. And right when they got it inside the well deck, they try to close it as quickly as possible to keep the waves from sloshing it around. So there's a couple of videos on YouTube where they show the recovery of it and how it looks, and it can be precarious. But what they do is they tow it at speed, and then they have the drogue chute or the rib behind it, keeping it straight. And it helps to dampen some of the wave influences on it. And they also try to go into the waves so that they shield what's behind them from the waves. And it helps reduce all the motions, and they're good at what they do. When they have the well deck ship, they operate it all the time.
I have a question here from John Barkio. How many years does it usually take to go from concept to design to final vehicle for something like the Orion capsule?
It took us the better part of 9 months for this one, for this specific test. But for some of the model boats that we would make for the mask, maybe 6 months to a year, depending. It all depends on what data do they want. A lot of times it's motions data, it's sea-keeping, or it's dynamic stability. It's very requirements driven or circumstantial. But yeah, go ahead.
Yeah. No. So for our specific thing, that the specific testing we were doing, that's definitely what happens. For context, we started doing this work where the capsule itself had already been designed. And then when I did my rotation with NASA in 2018, they were working on the actual capsule testing. So I did get to see it, which was super cool. But they were still working on it. So that was 10 years later. And we started when they already had a design. So this specific design has been in the works for over a decade. And they only sent up I guess this was the first one that went up. They sent up a couple of tests, I think. But so it won't even have people in it until, it won't be ready for prime time for another year plus, whatever their timeline is right now. So it can be decades. Yeah.
Yeah, tying it for the Navy ships. Yeah. See, Laura and I and Mark started at a similar time. We saw one ship design working on a case. Yeah. Yeah. Yeah, the Zomwall, yeah, strange looking ship. And I think it did get fleeted for like almost 15 years. And then we finally, I certainly got to be able to actually go on it. Bizarre ship. Interesting design, all that, but just getting it to that point. And there's also that preliminary period of like, what should we be building? What sort of designs we want to, just generally looking at, okay, where could we go? And then finally deciding on a priority, then focusing on that. Building something as big or as complex as either a spacecraft or a Navy ship takes sometimes decades. And there's lots of work on in between to start and finish.
Yeah. So speaking of a lot of things that have to go on. One of the, we do very specific types of work at Card Rock, and there's a lot of different things we do. And we'll jump back into the different types of, like, we had that picture of a bunch of people. 90% of the people in that photo, maybe not 90%, most of the people in that photograph were our technicians. So they were the ones that were making all the boilerplate. They were putting everything together, working with, the engineers and Mark to do the design. So it's kind of like we have the gamut of all these things going on in the background. And when I went to NASA, I saw exactly the same thing. I saw technicians working on and machinists working on building things. The person I was shadowing was looking at, 5 to 6 different tests a day, sometimes 2 calls a day. I was like, I don't know. I was like, I wanted to work for NASA. Now I'm like, I'm going to watch you work for NASA and be amazed. But they had all of these tests going on all at the same time. And we kind of operate in the same way. You have all these things going on in the background. And I think a lot of the times, at least for me, an insight was, oh, why does it take so long? Like, our phones can launch things now, like you compare it to what, the Apollo thing was, that phrase is, oh, our phone has the same amount of computing power that Apollo does. And I'm like, there's a reason for that. It takes a long time to get, from idea to execution. And sometimes the technology is, surpasses it for the things that you really need it for, but lots and lots going on in the background.
To go back to actually a question you had, when we were talking about the DDG-1000, the Zumwalt class destroyer, which it looks like almost like a diamond front, if you've ever seen it, or the old stealth fighter, the F-117 has that kind of triangular shape. We had several models of that. We had smaller models that we would test in the mask. And a lot of times we'd have to ballast them the same way, but for different reasons. And we had a resistance model that was a lot bigger because we would put it in the tow tank. What's that? For resistance, they have to determine how much power they need to give it. So they call it an RNP, or resistance and powering test. And so they'll make a bigger model and they'll drag it through the water, and they'll get the forces that act on that hull form and how the water interacts with the hull form. So they'll get that kind of feedback, and the bigger the scale, the better it is for them because of scale effects, fluid effects. What's it? Fruit scaling. Yeah. So the bigger models were always kind of wanted for resistance and powering, and for us in the maneuvering and seakeeping group, we would want smaller models because we were limited by the size of waves we could throw at the model. And we would be tasked to throw as much waves as we could at up to Hurricane Camille, which was a unique hurricane that actually ran directly over a NOAA buoy back in the 80s or 70s. It's a long time ago, but it was the most immaculate data that they'd gotten from a NOAA buoy on a hurricane, and it survived, got great data, and so we would use it for everything. And we would do capsize testing. So similar scale, we would throw around sea state 8 at it, and they're big waves, and if it tipped over, we would say, okay, what's the speed, what's the heading, et cetera, et cetera. And there was also a maneuvering model that they made that they would drag in our rotating arm basin. So if you do ever get a chance to see the facility, whether online with a YouTube video or actually visit, there's a rotating arm where they can do an infinite turn, and you can see how the resistance is during a turn, and they would change the angle as it goes into the water, et cetera. So different scales for different purposes. And and I know there was one other Orion capsule that was made by NASA Langley, where they have this unique crane that has this kind of V cables that they would drop the capsule in motion into water to see how violent it was, what the motions were on the capsule. It was the same size, full scale, just like ours, but it was made a little bit closer on the technology side to the Lockheed. I think they had a much larger budget than we did. But they wanted it to survive the impact, to see how the waves would react or the water would react. Yes.
curious if you can tell us a little bit about what are the other different types of careers that are available at Carter Rock? You've told us amazing things that you do, and the theme that I hear is networking. So everybody seems to have their own unique activity that they do, and then they all come together and do a test and have field trips, or there's a lot of networking that happens. But I'm curious to know about that's my first question. And then my second question is, what advice do you have for anybody who's considering either a student, a young student who's thinking about it, or even a career changer, somebody who wants to do something different? How could they get their foot in the door?
To be honest, a lot of it starts with listen. Like I mean this quite literally. Listen to guys like Mark. Mark's explanation of what we do, like the resistance model, how that works, why that matters, and those are the types of things I heard as an intern when we were like doing wave count testing for DG1000. Also working with engineers who always keep you on the spot. That's why we love them. But hearing those types of things opened up a world to me to be able to go start those conversations with people I had no connection with. Like, oh, I'm working with you on this project. I hear this is what this is about. And they may say, no, that's not exactly how it is, and hopefully explain to me what the real question is or how to properly pronounce something. And that's all good because that's all part of the learning experience. I'm lucky in that my job as a scientific photographer, helping out, capturing experiments and how they happen, opened me up to a world where I could have that opportunity to ask lots and lots and lots of questions. I really got a good sense broadly of what's available out there. And just being able to have somebody like Mark to guide me a little bit. And there's lots of other folks who are more than happy to guide me, especially as an intern. Going around asking people was also a great way for people to go, oh, that kid's got gumption. He's got some moxie. He's curious about what we do. And that sometimes is that's your literal foot in the door, just getting that opportunity. Like, I'm curious, tell me more about what you want to hear. And people will tell you all sorts of stuff. And that's the best way to find out what's going on. But I'm also in the middle of myself into a career change. And applying those same skills forward. I've enjoyed my time as a S&T photographer, enjoyed working with all this sort of stuff, but I developed other interests as well. By talking to other people, I saw other pathways are available to me, and I started doing, how did you get here? How did you get there? And a common theme for many people is they knew somebody who could tell them a little bit, could put them on a path that made an introduction. And living vicariously, like, okay, that's how you got to where you're going. That's what you're working on. I'm now currently working with another Navy organization who buys IT systems, not necessarily like big servers and stuff, but more like software, your ServiceNow, your Salesforce, your SAP, Unity, SAP. That's our ERP. I'm sorry, I don't know what SAP stands for. It's just such it's a huge software company that provides IT services, your ticketing systems, your HR systems, all those types of things. How the heck is a photographer jumping into that world? That wasn't possible without talking to a lot of people to understand, okay, that's what you do? Oh, how it affects people? But I bring to the table all my previous experience of understanding how to design a photo system to capture an experiment. You really need to understand what it is they're trying to capture. So you need to understand what it is they're doing and why are they doing it? Why does that matter? How can I apply my systems, whether it's a camera or a bunch of cameras, a high-speed camera, or even just how I record it in order to ensure that I can capture it. It's not like a movie set where you can say, cut, let's do that again. I'm not feeling it right now. It's like, nope, explosion done. Where's the video? You don't get a second chance. And going through all that sort of stuff is the same skill set you need for understanding how business works, understanding design, or asking good questions, or like doing the right sort of thing. It's been an enormously fun challenge to go down that route. So that's kind of how I'm doing it.
The first part of your answer was also my answer, but dang it. To piggyback on that, I think one thing that I learned, I think a little later than I would have liked to, is that you're wherever you are. I think this works in academia, in business and government. Your leaders are willing to talk to you. So that was something that I learned when we went through our leadership cohort is if you ask, someone is more than willing to give you a little bit of mentorship or a little bit of guidance. And that was huge for me. I spent the majority of my career up until 2018, 2017 doing the kind of the same thing. I liked it. I learned a lot. I got to do different pieces inside of that. I think we all kind of did the same thing. We were like, oh, wait, there's more stuff I can do. But as soon as I started saying, hey, can you tell me, like what Ryan was saying, hey, can you tell me more about this? I'd like to do this. I'd like to be the person that works on X, Y, and Z for you. Would you give me an opportunity to do this? People are much more likely than I thought to say, yes, I'd like to give you this opportunity. This exists. Oh, you would like to do that? Let's find a way to do that. And that was kind of an eye opener for me. I thought that it was just scary that you just didn't talk to the leadership. And, oh, they're going to tell me what to do. But taking that step, one of my mentors was telling me, because I credit him for helping me get my rotation to the Office of Naval Research Organization, Naval X. And he said, no, you took the scariest step, which was to actually talk to me and then go do it. You actually did that thing. You took that leap after you got your guidance. So that would be the other thing, is say yes. Sometimes you'll get like saying yes opens up the floodgates. You're like, oh, you like to do these things? Here's a bunch of stuff that you'd like to try. You're good at it. Do the thing. Like, oh, wow, I'm so overwhelmed, which isn't always bad. But saying yes to things also tells you what you don't want to do, which is really helpful too. Mark, do you want to talk about that?
I changed positions. I mean, I worked 12 years and a bulk of them with these two in the mask. And then I went, and a friend of mine wanted me to go into a completely different group, which was electromagnetics, and build a mag model, which was almost as challenging as the Orion, the boilerplate that we made. And at the time, I remember calling up Ryan and asking him if he could help us document us putting this all together. And he set up a time lapse, which was a really cool time lapse when it was edited back down and Ryan gave it to us. We saw this whole break apart of, let's just say, a vessel. We took this vessel apart and we had to pull out certain pieces, and then we had to put all these things back into it and add more to it. And it was this long, weeks-long process. And it was a really cool thing because I was new to that group and Ryan helped me to document it. And they weren't thinking about how they were going to document it like this. And so it was like, we all put our heads together and figured that out. After the electromagnetics group, I went to another group in manufacturing, and that wasn't quite my cup of tea. They were a little bit too, it didn't fit for me. But I knew enough people. I was actually a customer of the manufacturing group, and they had asked me if I wanted to work with them using AM and making parts and also metrology, like I said in the beginning. And I knew enough about both that I'm like, sure, okay, let me try that. That's maybe a path to a higher grade at the time, but that wasn't the only thing. It was still going to be doing design work and doing additive, which I still love to use. But that didn't work out, and I ended up still in a kind of hybrid position where I'm still kind of designing, manufacturing, and working with my old code 85 mostly, and 86, which are surface ship and subship groups making models for testing of all shapes and sizes and other articles. So
Cool place like Carter. I mean, one of the best parts about it is there's so much interesting work to do. Like a crazy amount of just cool stuff. And a lot of our folks work there for their entire lives. but there's not that many who work in exactly the same thing for their 30, 40, sometimes 50-year, like rich careers, like in the same area. There's very few people. That's actually extremely rare. Most people evolve and jump from one group to another and find opportunities. And some people wildly jump around, and there's just so much to bounce around at a place like Carter Rock, which only has about total, including contractors, 3,000 people, a little less, with sites around the country. We're part of a 50,000 person organization that oversees that. And so that network of even just the three of us at this table connect to a significant number of thousands by association. And the cool thing too about being a federal worker is you can you have that job security to go try that harder thing, and you end up working on some of the more interesting problems. Growing up, I thought working for the federal service would be the most boring thing you could possibly ever imagine, and it is never boring. It is always fascinating, like just the things we have to do. It is still federal work, and it can be very challenging at times, and sometimes like, why are we still trying to fix this problem? But that's also the cool thing, is like there's usually really interesting reasons why, and it's never boring. Really cool.
And I was to your question about the different, we're kind of talking about the different careers, but when we did one of our previous collaborative events, we did sort of a Ask Me Anything with the young professionals, and we had folks who worked in our contract shop, people who were working in our graphics department, people who were engineers, people who were scientists, technicians. And so there's literally any career that you could do, to include probably theater, is you could find something related. So we have people who write scripts for when we do videos. There's a couple on YouTube where we have people that have to be writers that have to help write a script so that we can prepare for these interviews and such that we're doing. We have, if you're in you're a creative and you're in arts, we've got photography. We've got people who do beautiful graphic design for our internal messaging and our external messaging. And you've got, I don't know, maybe music is the only thing, but even so, like you have to, there are skill sets that you can apply to everything. We have.
Yeah, like, yeah, IT, like we have to have all their systems. We have to have all this stuff running. We have specialists who know our mission. Do we have contracts folks who write the contracts and negotiate the deals we have to make to buy the really interesting specific things we need. We've got HR folks, because with 3,000 people, there's going to be 3,000 problems. There's and all the things that go along with that. And it's pretty much at every point in the organization, even if you're not involved directly with science or engineering and stuff like that, or even NASA for that matter. That's only a fraction number of people just at Carter Rock who worked on this one NASA project, all working on this really cool mission together. And it quite literally, the headline is scientists or engineers solve this problem, but it takes lots of other people. So you can be directly connected with some really cool stuff, even if it's not explicitly science or engineering or other STEM type stuff.
I meant to actually address that too. That we did take there were a lot of classes and a lot of other activities that happened that we had to go through for development and learning about Carter Rock. And during those classes and times we're in a classroom setting, people from all over Carter Rock that, hey, what code are you in? What division are you in? And you talk to people, and I met a lot of people like that. And then when I jumped to different groups, I met a lot of people in those groups, just kind of a little bit of a social butterfly. But I talked to a lot of people, and to find out, because there's so many different facets and so many different experts in different fields. And the IT group in one division actually does stuff a little bit different than the IT group in this division, and their structure is different, or they have different group policies or other things that they apply. And so you have different things, different approaches, different structures, different bureaucracies in these different groups. And I would say, oh, I know somebody in this group that does this and they do it like this. And it would give people in the group that was kind of on their own island, isolated and not knowing the processes from another group. It's almost scary sometimes. You can kind of get isolated and in the mask, we were a building that was on at the end of our facility. And if you didn't get out of the mask, you actually kind of felt you were on an island. Yeah. We call it the bat cave sometimes because they didn't use chlorine in the pool. It's actually just city water that we fill the basins with. And in that building, there's 20 million gallons of city water between the two basins that we have. And we couldn't use chlorine because, well, they said they would just use darkness and keep the algae from growing in the basin. So it was easier that way. You wouldn't have to deal with all the chemistry and rusting. It still works. We still get rust, but not nearly as bad. But anyways, it was networking, like you said, it really getting to know people and talking to people in the cafeteria sometimes, sitting at a different table and just getting to know people, and you find a connection, and next thing you know, you're helping each other out, you're collaborating on something.
Can I add a little bit to what they were saying? Yeah, I work with these guys that do work very similar to theirs, but just maybe a little more philosophical at my age. But for young people in this room, the main thing I would say is just pursue whatever you're interested in. That's the really important thing, because you never know what the future brings. And in my case, I'll just briefly tell a little bit about my background, just to give you an idea. And that is my master's degree was a wind tunnel test of an airplane. Okay, my next job was I was a missile launch officer in the Air Force. So I do literally no rocket science. Okay. And and so now I work with guys that do primarily surface ship model testing. And the other piece of advice I'd add to what Mark was just saying, the other important thing in your career is networking. And I will tell you, literally every job I've had in my career, I knew somebody.
We have heard so much amazing information. You showed us beautiful pictures that you've taken, very professional photography. So thank you for that. This is where we open it up for questions. We've had some questions throughout, but if there's anybody else that has other questions, this is the time to do it. I can pass the microphone or
regarding the capsule, when it lands in water, what's the speed usually? And also, what is the impact like? How did you go about testing that?
They actually design their own parachutes, slow it down to like, I think what they characterize as acceptable. Thought was 2 seconds. It's bouncing around up my head. They did mention to us when we were doing the design, and another time to make sure that the FEA and solid to try and make sure that the box in wave slap and that they find but they also primarily try to keep it possible, but it's pretty good point.
and we didn't test the ball.
Right, we didn't. That was the language. The impact testing. They also had criteria for what's acceptable. Because they had told us that when the astronauts, I think it was discussed before, that when they come back, it's assumed that they would have been exposed to zero gravity for a prolonged period of time, And then because of reentry, they would be spent. It would be shaken up so hard and basically beaten up, being held by the restraints in their suit, that they would be assumed dead weight, right? Just kind of and so the parajumpers, these were pretty strong people, and they would get in there and they would literally have to drag them with their suit and get them over the edge, dump them down into the rib. And that was their task. And that's why we had built this, for that purpose. But they said they would always just treat them, assume that they're a rag doll. It's just, I think I might have lost track of what your question was, but I apologize.
That's it. The only thing to add to it is, like you were saying, the inputs that they gave us for what they were going to test for, we made sure that that was something that was captured in our model as far as what it needed to be, what it needed to be like.
Do you have any other questions? Anybody in the chat?
Rundown that, because I can't help but think of, like, doesn't sound like you're building buildings in the middle of the ocean. It's almost related to waves.
Yeah, no, good question. So I would say that a lot of the folks at Carter Rock are actually naval architects, which is building boats. That was not something that I was smart enough to do. I took a naval architecture class.
What is your under?
Aerospace engineering.
yeah.
They're very different. They're very different. But ocean engineering was more about the ocean itself, whereas naval architecture is about the vessel that is in the ocean. So a lot of the classes I was taking, I did take a naval architecture class, but a lot of it was about the waves. It was about the interaction of whatever the thing is, typically a boat in the water, moving that thing. My favorite class was on waves, though. That was pretty great. But yeah, the ocean engineering is not building.
I was thinking oil rigs, like.
But it's related. It's related. Yeah,
When-
it's related.
When I was going to college, initially, I was at a community college at Palm Beach Community College down in Florida. And at the time I was working at TGI Fridays. And right before my shift started, I sat down, I was a host. I sat down next to a guy who happened to be an ocean engineer. And we were talking. I'm just basically shooting the stuff with this guy first. And I was like, yeah, I'm going to school. I think I'm going to be studying ocean engineering. Oh, I'm an ocean engineer. He's like, oh, I'm getting ready to go to FAU. And he's like, well, I went to FAU. Oh my gosh. And he said, don't do it. And he said, he said, you're going to work in oil and gas, or you're going to work with telecommunications, laying cable in the Atlantic or the Pacific or somewhere. And at the time, I mean, that was what was big. And this was in the 90s. But he said, you're going to travel a lot. It's going to be hard to have a family, et cetera. But I think there's more facets of it now. But naval architecture was more like Lauren said, like Tink said, you're going to design the ship and how to handle waves, or what your conditions you're going to be in, where you're going to operate. Like certain ships, we say, oh, okay, this one's going to be in North Atlantic, or this one's going to be in the Pacific. We might ballast them differently. But you have to look into those fields and make sure that you dig in, maybe even find somebody that's in the field and ask them. I participated a lot with ASME when I was in school, American Society for Mechanical Engineers, and a lot of clubs actually in school. And I did a lot of traveling and learned a lot from different people across the country while I was in community college. And it was some of the most fun time in my life. I mean, we traveled, we had national conventions and networked with tons of people. It was a really good experience.
Some other questions, really quick. Can you talk a little bit more about transitioning from community college to FAU, or like how that path happened, being for a community college?
It was
Yeah.
a messy path. It was a long path. Didn't have too much money, had scholarship. Top 10% of high school graduating class could go to community college for free in Florida. And if you maintained the GPA and 40 credit hours per year at the time, you could transfer into FAU and be tuition free the entire way through, which was a blessing because I could not afford college. And the offers I got from FSU and UCF and U of F were not going to cover it. So I took advantage of that, and I got a couple of years into community college, and then I had to work. I worked at Motorola in a factory there for a couple of years, and then worked in their engineering department as a student engineer for a couple of years, which helped me to get through college, but it slowed me up because I was using that money to help pay for college, and I lost my scholarship because I wasn't paying attention. And I did 38 credit hours instead of 40 one year, but having that name and that experience got me, it helped me a lot. I mean, and I got into FAU and just hunkered down and worked with the good students. There were some other kind of students that weren't so good that we didn't work with, but I networked with the right people, and we all studied hard and worked our way through. Yes.
Are there other types of engineers that work harder off, or is it all Navar?
Well, in the group that I went in it was hydromechanics. So there were a lot of, it attracted a lot more naval architects, like aerospace engineers, mechanicals every now and then. And a lot of times when I was there, my title was actually, I think, general engineer. And I would still treat everything mechanically, and I would do designs for these models and get them set up and ballasted. And I would work with a naval architect. And then we had electrical engineers that would set up all of the data acquisition systems. We had people that would do software sometimes we would, yeah, sometimes we would do our own software depending on how complex the system was. And we'd work with the electrical engineers. But for the most part, and there were times when we did joint collaborative tests with the materials group, and they would have slam panels and pressure panels and other devices, and they would collect data a lot more rapidly than we did. We only needed to take X amount of points per second. They would take thousands of points per second because they wanted impacts from the waves. And so we would have to work with them and incorporate. So they were material scientists or material engineers. They were kind of mechanical spin-offs, but materials engineers. And I think they even had, yeah, chemical and environmental engineers. They had a few of those in the materials group because of some of what they do for the recycling and other chemical and water treatment plants and systems on board ships. And we have systems, and yes, my gosh, program managers and, but yeah, in the group that I work with signatures, there were a lot of electrical engineers and a lot of physicists that worked in the signatures group, a lot of acoustic engineers. I mean, that they were in the realm of, you could say, a break off from mechanical, but it was almost all vibrations and acoustics, it was always hard for me when I was in school, but.
And I would say that I think the three of us, even our photographer over here, we had an opportunity to kind of test out other things. So while we were still like, I guess administratively, I was an aerospace engineer for a while, then I was a mechanical engineer, then I was a general engineer. And that was administrative, but I got a chance to do a whole bunch of things. I didn't actually use my aerospace engineering degree as an aerospace engineer. I did much more software. Well, I didn't do a lot of software design, but I did a lot of electrical engineering and mechanical engineering that I didn't actually learn in school. So I guess another, I don't know, piece of advice would be, whatever it is that you go into, you're going to be able to branch out when you go do something else. And I think that's not something that I thought I was going to be able to do. When I got my internship, it was one of those, again, it was a network thing. My dad had a friend, my dad worked, was active duty in the Coast Guard at the time. One of his bosses or friends had a friend who happened to be my first boss, our previous boss. And they were looking for interns over the summer during a hiring freeze. And they were like, well, we can't hire people, but we can bring in interns. And I was like, I need a job. So I interviewed and they were like, sure, you're summer help, go do the thing. Now we have much more rigorous, much more structured intern programs where you get a chance to see different aspects of Carter Rock, which is, I mean, I really liked coming on as an intern, but it was very different than what we have now. But you get a chance to do everything. And I think Ryan, of the three of us at the table, probably knows more people at Carter Rock than we do combined, simply by being a cross-cutting function. So we have engineering departments and we have a bunch of business and support departments that cross-cut that. And our engineering departments cross-cut as well. Like we're in our hydro department and we work with our structures department, and sometimes we work with the signatures department, but the photography department is across everything. Our contracts works with everyone. HR obviously works with everyone. So you get like this nice matrix of groups where someone says Hanyok and I get his emails because they're like, that's Ryan, right? Yeah, that's a Ryan. Because he knows so many people just from the nature of the job that he was doing. And then that, like, as he said, led him to what he's able to do now.
I have to answer. But let me tell you about a hot dog. So just back in college, and just kind of, if you keep hearing a theme, I'm going to hammer it in further. So my college experience being fine arts, I knew I was not going to get paid a lot. So I needed to, hunker down, save as much money as I can, come out as little debt as possible. That being said, I got the most out of it, and how it all made it possible really to come out with very little debt. And additional opportunities and additional skills was I applied to be a resident assistant. So I guess you don't have people live on campus here, but a lot of universities do. You live on campus, you typically have a fellow student kind of keep eye on things, and I applied for that. I actually did not get it. I probably said something stupid in the interview. I was probably being a smart ass as I typically am. I don't know why I didn't get it. But that's okay, so, all right, well, I'll try and figure out something out next semester. I'll go get a second job or something. Then they advertised a little bulletin, flyer, free hot dog day or whatever. So I go outside and literally that's what it was. Free hot dog day is just towards the end of the semester, go out in the patio, go get a free hot dog. I'm not hungry, but I'm a college student, so why not? And there is the resident director, the guy who interviewed me. And said, hey, how's it going? And so, oh, go pretty good. Hey, are you still interested in being an RA? He's like, oh, sure, yeah, I'd love to. He's like, great, somebody dropped out. So there's a spot open for you. Had I not done that, he may have gone back to his list and look at possibly higher candidates. I don't know, but the fact that I got a free hot dog got me free housing. And in addition to that, and just sometimes, especially when you get into the workforce, or if you're currently in the workforce and those events may be like, I don't know if I have time for it. On occasion, just take time to get involved, just to check in, maybe open up your world a little bit. The job I'm currently doing now, I met through a guy through Lauren who came to see our band play an event. And then 2 years later, he had an opportunity. And probably not going to throw it on the list again, but it's like, hey, you interested? It's like, yeah. So, and just happened to be perfect timing in that respect. So had to been a year earlier or a year later, it may not have been of much interest to me because maybe my path would have been such, but perfect timing. I could not plan for that, but I took the opportunity, said yes. So yes, say yes, take free hot dogs and life will turn out good. Any other questions? Condiments?
I was going to say to that is a lot of the times I think the trope is, oh, you come into a place where like this, where you'll have these random interactions. And I think, yes, you will have those random interactions, but if you're intentional about the interactions, you put the engagements you put yourself in. So coming to an event like this, going to get a free hot dog, intentionally, I'm gonna get a free hot dog because it's going to help. Those intentional events are going to create the random happenstance engagements that you end up having. And I now that like I said earlier, now that I've kind of, that insight has, switched on, I do that now. I live my life that way. I'm okay. I'm going to go to this thing because something's going to happen and I'm going to find that interaction that's going to benefit somebody in the long run. Cool. Thank you.
Thank you, all of you, for being on this panel, sharing your experience, teaching us about your experience at the Orion Capsule and what that was about. And thank you, all of you, our audience in person, also virtually, for spending time on a Monday night here at the Hub. We really do appreciate that you have so many choices of what to use your time for. So the fact that you chose to be here is meaningful. So thank you. We have, of course, a survey. We'd like to know what your experience was like here. So we can continue this type of programming, bring these type of speakers. So there is a QR code on the screen and perhaps a link in the chat as well. Yes. Okay. So please fill that out. That we really do look at that feedback. While you're doing that, I'd like to tell you about our other programming that's coming up. So as I said, this is our first Fireside Chat for the spring. The next one is going to be in March, also on the first Monday of the month. But next week, we have our first Future of Tech Lunch and Learn. So the theme always is food. When you come to the Hub, you will have a meal. And hear some great programming or participate in a class. But so our next speaker will be Jabari Jackson, and he's going to talk about Salesforce and how customer management, what does the S stand for? Service, CMS. Well, you know what that means. I also need to be present at that chat to learn about, no, I'm teasing about it, but he's going to talk about how to engage your customers, right? It's a customer management system. That's what it is. I knew it was in there. So please come back for that Future of Tech. It will again be in here, same space. Registration is the same. If you want to join us virtually, sign up on Zoom. If you want to be in person, sign up on Eventbrite. This presentation and all of our presentations are recorded on Zoom. We have a YouTube channel, so you can follow us there and watch our presentation. So you can tune in and watch, yes, relive this panel presentation. But again, thank you for that. I hope you filled out the survey. I think there's some food still left over. So there are to-go boxes. So please make a box and take it to go.